Hi, Jacqueline. So I wanted to go over the two questions that you sent me. Let me go to the first question first. So the first question you sent me was 8.1.19. And in that question, you asked, well, this was the information that was in the question. First of all, it gave you the test statistic was 2.04, and the claim was that P does not equal 0.851. And the first question was what type of test this is. So the type of test, because it's a not equals, this is a two-tailed test. Anytime it's equal to or not equal to, it's a two-tailed test. So then it said to find the p-value. So this is a capital letter P. And so you're supposed to find the p-value. So what we're going to do is I'm going to give you an idea of what's going on. Is we're going to draw our normal curve, right? And we know the test statistic is 2.04. So that test statistic is right about here, okay? And it's 2.04. We're going to use our calculator and we need to find the area. Here, let me change the color. So we want to find the area. We want to find this area, which I've highlighted in yellow. So to find that area, anytime we're finding area, we use the normal CDF function, right? So I'll just write what that will look like on the screen, right? But the lower bound is 2.04. The upper bound is a big number like 9999. And the mean is 0 and the standard deviation is 1. And when you plug that in your calculator, I forget what that is. Let me look it up. So second distribution, normal CDF. The lower limit is 2.04. And the upper limit is 99999. And the mean is 0 and the standard deviation is 1. And we get 0.0207. What makes this a little tricky is that's this area right here, 0.0207. Let me put that in a different color for you. Here, I'll put it in green. So that's 0.0207. That's right here. But we need to consider this area of 0.02072. So what we have to do is we have to multiply that by 2. So our p-value, we're multiplying by 2 because it's a two-tailed test. Since it's a two-tailed test, our p-value is twice this number. So the p-value is 0.0414. Follow the directions on my math lab. I think it said I can't remember if it said to round to 2 or 3 places, but you pay attention to that, okay? So then we want to compare that to alpha being 0.01. Well, if alpha is 0.01 and we have a two-tailed test, that means that, do you see this p-value? So alpha is 0.01. We're going to divide that by 2. When we divide that by 2, it's 0.025. Or actually 0.005, sorry. 0.005. So it's 0.005. That's 0.01 divided by 2 because it's a two-tailed test. So that means we're comparing 0.0414 to 0.005. So here P is high because our P value is higher than this. So when P is high, null must fly. So since P is higher than that number, we fail to reject. Sorry, I'm starting to write that down wrong. So we fail to reject. I'll put it in a different color. Fail to reject the null hypothesis. Fail to reject HO. Okay, let's go to the next question. So in the next question, they gave you the test statistic. The test statistic was Z is equal to negative 1.47. It said the claim was that P is equal to 3/8. And the significance level here was 0.05. Once again, this is a two-tailed test. So the critical values was the first thing you're supposed to do, is to find the critical values, right? So here's the deal. Once again, I'm going to draw my normal curve. And since the significance level is 0.05, that means we're going to divide 0.05 by 2. 0.05 by 2. Why are we dividing by 2? Because remember, this is a two-tailed test. Two-tailed, we can tell that by looking at the claim. So the claim was that P was equal to 3/8. So anytime we have an equation in the claim, right? Anytime it's an equation, it's two-tailed. If it was less than, it'd be one-tailed. If it was greater than, it'd be one-tailed. Since it's equal to, it's two-tailed. And so the area in these two regions have to add up to 5. So that means they have to both be 0.025. So let's think about this, Jacqueline. So now we know the area. So when we know the area and what we're looking for is the z value. So we need this z value and this z value. And we know the area, then we're using the inverse norm function. Okay? So then when you go and you use the inverse norm function, your area is 0.025. The mean doesn't change. That's still 0. The standard deviation is 1. When you plug that in your calculator, I believe it comes out to like 1.97. So that's this z value. The other z value is negative 1.97. Okay, so that's where those critical values come from. Okay, so now we have to determine, all right, well, we have a test statistic of negative 1.47. Where would negative 1.47 be? Well, negative 1.47 is going to be right about here. If it falls in this region, in the middle, if it falls in between those two critical values, then we have to, we cannot reject the null hypothesis. So our conclusion is to fail to reject the null hypothesis, HO. So fail to reject HO is the answer here. So it's just a matter of when do I use inverse norm? I use inverse norm when I know the area and I'm looking for Z, and I use normal CDF when I know Z, but I'm looking for the area. I hope that helps. I know you did awesome with that earlier, so I think that hopefully this will help you, but I'll talk to you again tomorrow morning at 7:30 about this. Hopefully you'll have a chance to look at this screen